morning, members. On this page, once again, we have come back to look at chemistry. Remember, we said that we shall be taking in biology and chemistry. So today, our area of concern, we are going to look at what we call rate of reaction. Rate of reaction. We have been opening the question bank, and you always see many questions which are probing you to give some answers concerning what we call rate of reaction. You have already seen, or you some time back you observed that reactions do not move at the same pace, do not proceed at the same pace. If I'm going to use a local example, let us go back in the kitchen where the food is coming from. You'll discover that when you put, for example, water in the cooking oil, you see that the reaction is going to become vigorous. Girls and some boys who are good in cookery can testify. The whole saucepan can even catch fire. Then when I drive you back to the laboratory, you always tell you don't add the water to the acid. Don't add the water to the acid. Because when you add the two, you always see the reaction is becoming more rapid. So when you go back seeing some preparations of gases, you always see that they say add a catalyst to increase the reaction, do this. This is the chemistry we want to talk about. The chemistry is simple, but it may sound as if it is too hard. This chemistry is very, very simple. Just follow me, comrades, and then we see that the science can be grasped very fast. So in this subtopic, we are going to mainly consider the following keywords. The following keywords should be taken as important. One of the keywords is going to be the rate. So make sure that word you observe it critically. Rate. Then another keyword should be rate of a reaction. Then surface area, concentration, pressure, temperature, as well as a tangent. So we have brought some part of mathematics of what we are calling a tangent. So those are keywords. Then as we are looking at this lesson, make sure at the end of the lesson, the following should be grasped. And actually at the end of the lesson, my students should be capable of defining the following. One, the students should, the students, you should be capable of defining what we call rate of reaction. You should also be capable of outlining the factors which affect the rate of a chemical reaction. Then, even to describe briefly how you can determine the rate of a reaction experimentally. So, meaning those are our learning outcomes. You have to be sure of those ones as we are driving through the whole chapter. So I want you to be careful as you're following me if you are going to understand everything under this topic. Now, when you are looking at the rate of reaction, already I've told you that we are looking at the speed of reaction. Speed of reaction. Don't become perturbed by the word rate. Remember, even in physics, you talked about rate. You talked about rate when we are looking at velocity. We are varying velocities in physics. So now when we come to rate, it's not something strange. Take an example, they are chasing you, and then someone come and make a grammar statement. The rate at which you took off was terrible. That one now is going to imply that the speed at which you are running away was very, very high. So at the same time now, we shall see that even our chemical substances in the laboratory or in chemistry, they also behave in the same way. Some of them, when you bring them together, they react violently, others slowly, and as they are giving off the products, some of them give products faster, others give off products slowly. Now when you connect physics with this chemistry you are talking about, you will discover that rate of reaction, you can only consider it by based on the time interval. How much time have you taken, and so on. Now, in simple terms, we are going to begin by defining rate of a chemical reaction. As you will discover in your notes there, which are moving on your screen, we can define rate of a chemical reaction by saying that this is the progress of the reaction in unit time. Or if you don't define it like that, still scientifically you can convince the teacher by telling the teacher that rate of a chemical reaction is simply the rate at which the products are formed, or the rate at which the reactants are used up in the reaction. So there are different ways how you can define rate. We can also define rate by saying the amount of products formed in a unit time, the amount of reactants converted into the products per unit time. So meaning, as we are looking at your work there, we are saying the rate of a reaction is simply the concentration of the reactants over the time taken. Or you can even say the amount of products formed in a given time interval. So as we are looking at the notes which are moving on your screen, you discover that we can obtain rate by saying rate of a reaction is simply concentration in moles per liter over the time taken. Now, we have so far defined the rate of a chemical reaction. At any time they can ask you what is the rate of a chemical reaction. So when you are defining it, you are going to convince the teacher the rate of a chemical reaction is simply the progress of a reaction in the unit in the unit time. Now, we are going to proceed as we have said. Let us try to move downwards as we are looking at your work there. So we are moving downwards. When you move downwards, our area of concern is going to be determining rate of a chemical reaction. Now, when you are determining rate of a chemical reaction, it implies that we have to take measurements of a particular product formed. And as you are taking the measurement of the product formed in of a particular substance, we have to base on the time interval which is taken. This implies that the gadgets which you are going to use, or the chemistry tools you are going to use here, you have to use tools which can enable us to measure a given product, or to measure the reactants which is remaining, or the reactant which is used up. Therefore, we have to use even the stop clock as one of the gadget or the tool which is going to help us to record the time which is taken. For all reactions, we can determine their speed at which they proceed. Remember, rate means speed at which a reaction is proceeding. That is now rate we are talking about. So from there, if you are going to properly determine the rate of a reaction, you have to pick the reaction which is suitable to you. You can choose and then you determine the rate of reaction. For example, between the rate of reaction, that is when you are looking at calcium carbonate and dilute hydrochloric acid. In that reaction now, you can determine the rate by either measuring the volume of carbon dioxide produced in the per unit time, or you can also try to weigh the amount of calcium carbonate which is used up in the reaction. One of the two can give us the best picture. Now we can also determine rate of reaction between, for example, magnesium and dilute hydrochloric acid. Here we shall be measuring the amount of hydrogen gas produced. Then even you can measure the mass of magnesium which is being used up or converted into the hydrogen which we are talking about. Now from there, we are also looking at, you can determine rate between hydrogen peroxide in presence of manganese oxide. That one, it implies that you are going to base on the amount of oxygen, which is the amount of oxygen being produced by the reaction. Now, when you look at your work, the work is basing on the now determining rate of reaction when you are considering magnesium and then dilute hydrochloric acid. What matters a lot in this experiment, you will discover that we have to get the flask. What matters is the flask. It can be a flat bottomed flask, can be a conical flask, it can be a round bottomed flask. Then after obtaining your flask, we are seeing that you are going to put in your flask, you are putting now dilute hydrochloric acid for that experiment. Now we are putting the magnesium where? Putting the magnesium now in the test tube, and the test tube we are seeing they are putting the thread. But now you make sure that you fit the flask with the delivery tube connected to a gas syringe. But remember, we are saying that the experiment should be a working experiment. So to prevent the gas from coming out, you are seeing that they are covering the flask or corking it. Now, from that picture which you are looking at, you will discover that as you are going to make the thread loose, the magnesium ribbons are going to pour into the dilute hydrochloric acid. And as they are pouring into the dilute hydrochloric acid, members, you are going to see that a reaction is going to take place. That is between magnesium as well as hydrochloric acid. And as the reaction is proceeding, of course we have an equation there. That is magnesium plus dilute hydrochloric acid to form magnesium chloride plus hydrogen gas. Now, the hydrogen gas being produced here, we are seeing that all the hydrogen gas is going to pass by the delivery tube into the singe. Remember, the gas singe is calibrated, is having numbers, and as the gas is being produced here, after you have even started your stop clock, the stop clock is now counting, moving. The gas is being produced, and the gas being produced is passing via the delivery tube and is climbing up into the gas singe. Now, when the movie reaches the gas singe, you will see that it pushes it because there is some pressure. As it is pushing it, for you can now be recording at after each 5 minutes. You look at your stop clock here on your, which you have put on your experiment. Then 5 minutes. Then you record where the piston is. Remember, I've told you, as the hydrogen gas is being produced, the piston is going to help you to know how much hydrogen gas is being produced by the reaction in the flask. Then you record the hydrogen gas, the volume, as well as the time which you have taken. Saying that after plotting our graph smartly, how are we plotting our graph? We are plotting our graph from the values we have obtained. That is, those are values of time, then values of what? Values of the volume of the gas which we have been recording using the glass syringe. So we are assuming that we have obtained your results, that is time, and your result, that is volume of this, and you have made the graph, you have plotted the graph. When you are plotting the graph, make sure the graph should be having the title, the graph should be having the scale, the graph should be having axes which are labeled. Then the graph should always be presented in what? In the pencil. But remember, the title and axis, you are labeling them in what? In the pen. Now, the issue is that determining now the rate from the graph. Now, when you're determining the rate from the graph, we are saying that you are going to draw a line touching your curve like this. Which line we are calling? You are drawing a line which is straight to touch your curve. And drawing a line straight touching your curve, then you are going to enclose your line by doing like that. In simple terms, you are drawing a triangle. After drawing your triangle like that, we are seeing drawing our triangle properly along our tangent or the straight line we have drawn. Then we trace the values on the y-axis and the values on the x-axis. You'll discover that on the y-axis we have y1 values and y2 values. At the same time, on the x-axis we have x2 values and x1 values. Now, when you are going to determine our slope, we are just going to get a change. In the difference in the y values divided by the difference in the x values. In simple terms, we shall get y2 minus y1 out of x2 minus x1. Then this. Now, when you go back to our graphs, the values of y, we have one value here, we have a second value there. Then values of x, we have one value there and one value there. Therefore, we are seeing that now our slope is going to be equivalent to the y2 value minus y1 value divided by x2 value minus x1 value. The figure, assuming here we add, for example, 40, let me just assume, and here you add 20. That one implies that you have now the 40 minus the 20, then divided by, assuming here you add the 20 minus 10 now. You now get your values as 20 divided by 10. Now the value we get here as our 2 will become now our slope, which is our rate. Now, the issue will be that the value you have got without the units is wrong. Now, remember what you plotted here, it was in seconds here. And what you plotted here, it was in cubic what? Centimeters. So our units now, as you are looking for our units, we have our cubic centimeters divided by our seconds. And now when you bring them together, our units will become cubic centimeters per second, which you can also represent as cubic centimeters per second. Like that, it is also accepted. That one we have considered magnesium and dilute HCl. Assuming we are going to consider calcium carbonate and dilute hydrochloric acid, it means in that figure 11.1, you'll put your calcium carbonate in the conical flask. Then you'll put now the dilute hydrochloric acid in the test tube. The setup will remain the same. Then you'll make the thread to loose. Then what are you pouring? You're pouring the dilute hydrochloric acid into the calcium carbonate. So when you pour the hydrochloric acid into the calcium carbonate, we are seeing that, of course, bubbles of the catalyst gas are going to be given off. That is when you get calcium carbonate plus dilute hydrochloric acid to form calcium chloride plus carbon dioxide and water. Now our main focus is on the carbon dioxide produced. The carbon dioxide produced will go where? Will pass via the delivery tubes to the gas syringe. Then the pressure the gas exerts on the piston of the syringe, the piston will move backwards. So if you take a note of time, you can say, let me jump 5 minutes, I record my piston where it is, I record the figure. Another 5 minutes, then those are 10 minutes, you record the piston, you record. In the same way, members, you plot a graph. That is a graph of the volume of the carbon dioxide recorded over the time taken. Now after plotting the graph, you will still draw a tangent and you get your rate of a reaction. Now you can still do the same when you have, for example, an experiment of hydrogen peroxide and manganese 4. That time it means you put manganese oxide in a conical flask, then you put the hydrogen peroxide where? In the test tube. Then you will produce oxygen gas, which oxygen gas you will record in the what? In the syringe. So I'm assuming there we are moving on smoothly. Now after understanding that, members, we can look at the factors which affect the rate of a chemical reaction. There are many factors which affect the rate of a chemical reaction. However, the major ones will include